Okay, so let's talk about our other normally distributed variables that are not standard normal, like we talked about last time. And this one should probably be a considerably shorter discussion. So let's move on. Why is it... And there's a couple of different ways that we can go about that. We're going to be using our calculator for other normal distributions. Now, method one, we can standardize everything. So method one, okay, third time's a charm. So here we have method one. You could standardize the points in question, turning everything into standard normal, and use all the techniques from the previous section. Or you can use normal CDF and plug in a mu and a sigma. Now, for areas to the left or percentages less than a certain point, just make sure that your lower bound is less than 5 standard deviations below whatever the mean is. Make sure that your upper bound for areas to the right is more than 5 standard deviations above the mean. Sometimes 10 works, sometimes 99 works, sometimes you need 10,000, who knows? But you just have to make sure, and you don't have to figure this out exactly, you just have to make sure you're over that point. And then everything else is the same, except for we're just going to put in a mean and a standard deviation. So let's do some examples. Now let's talk about IQ tests. IQ tests are normally distributed. They're made to be like that. They're not very accurate, but they are normally distributed. What is the percentage of people who score on an IQ test between 115 and 140? Average is 100, and sigma is 16. Now, we could standardize them, and we can put this into the calculator just like this, 0.94 and 2.5 using 0 and 1 as mu and sigma. Or we can put 115 and 140 in the calculator using 116 as mu and sigma. So what we can do is we go to our calculator, we turn it on, we're going to go normal CDF, because remember, I'll write this again. Oh, come on. Normal CDF. So we use normal CDF when we're going from z-scores or x values to areas or probabilities or percents, and we use inverse norm when we're given areas and we're going to find z or x values. Okay, so let's find this. So we want normal CDF. So those of you who do not have a menu that comes up, you're going to put in your lower first, which is 115, comma your upper, which is 140, comma our mu, which is 100, and our sigma, which is 16. And then you just hit your paste key, and it does exactly what I just wrote here. And our answer is 0.1680. So about 16.8% of people have IQ tests between 115 and 140. So what is the percentage of people who have IQs under 110? So 110 is going to be right in here somewhere. So we want this area below this. Okay, so what we're going to do is we're going to do normal CDF. and we want below 110. So we need to make sure this over here is more than 5 standard deviations below the mean. Well, 5 times 16 is 80. So you know what? I'm thinking 0 will do just fine. So we can actually go from 0 to 110, 116. So let's do that. So we're going to go from 0 up to 110. And we get 0.7340. So, or percentage, 73.4% of people have IQs under 110. So what is the percentage of those with IQs over 125? So we want the normal CDF. We want to start at 125. So that's going to be, let's see, this will be 130. So about here maybe. And we want to go this area here. So we want to go up to a positive infinity. So 125 up to something more than 180. So 200 I think will be sufficient. Oops. And 116. Okay, so let's try it again. Normal CDF. We're going from 125 up to 200. You could have just as easily used 300, 400, 180. It wouldn't make any difference. You could make these whatever you like. You can make them 999. Just don't use 99. That wouldn't work on this one. So this is going to be 0.059 or 5.9% of people have IQs over 125. Okay, so now let's talk about working backwards. So if we know a percentage or probability and we want the values, we use inverse norm. Again, we have to give it area to the left for the majority of your calculators. There is a few of you, like I said, who will have calculators that you can actually change that to right or center. And that's wonderful that you can do that. So, what is the 99th percentile of scores? Now, if you remember percentiles from taking your SATs or what have you, you know that the 99th percentile is the point at which the X value at which 99% of the scores are below. So, that's the same thing as inverse norm. Oops. 0.99 mean SD 116. So let's find this. So we're going inverse norm now. 0.99. The mean is 100. Standard deviation is 16. And we get 137.2-ish. So about 137.2. If we wanted to round that off, we say 137. So what value does 60% of IQ scores exceed? So we want a 60%. Whoops, that's not 0, that's 100. So we want to go, we know it's below 100 because 50% will be above 100. So we know we have a point about right here. And this is 0.6. Now, INV norm requires an area to the left. So if the area to the left is 60%, or the area to the right is 60%, what is the area to the left? Hopefully you cried out at your TV or computer or whatever you're watching this on, 40%. So we want INV norm of 0.4, 116. So let's do that. 0.4, 116, and we get 95.95 or 95.9. You can just call it that. 95 point, what did I say? 9? yeah, whatever, we'll call it 95-95. So 95-95 is the score at which 60% of IQ scores are higher than 95.95. So this is where things get a little more interesting. What two values represent the middle 80% of IQ scores? The middle 80%. So we want 0.8 in the middle. We're going to call this A and B. So we want to know what this A and B are that 80% are in the middle. Now this is symmetric about 100. It's not symmetric about 0. So these aren't positive and negatives of each other. So if the middle is 80%, what is the total tail area? So the total tail area is 20%. So each tail must be 10%, or 0.1. So it means to find A, I'm going to use the inverse norm of 0.1, 116. To find B, I need 1 minus 0.1. So I need 0.9, 116. So let's find those. So we have inverse norm, 0.1, let's start with that one. And that is 79.5, we'll call that. So A is 79.5. B, I'm just going to cheat. I'm just going to do it this way. Call that back up. Oop. It went crazy on me. It went nuts on me. Oh no. It's still going nuts on me. It's turned red. Which means I'm going to start over completely. Because every time I close this and open it, it clears my RAM. Okay. So, I couldn't cheat. Didn't like me to cheat. 0.9, 16, oops, 100, sorry, and 16. Paste, 120.5. And so now we know that the middle 80% of IQ scores fall between 79.5 and 120.5. So the average 80% of people are between here, which makes sense. Okay, so this one was pretty short today. So I hope you do watch the video for Against All Odds as well for this section. It's really interesting, and it's important that you guys watch those videos as well. Because they really do kind of portray some real world applications of what we're doing.